So we're going to look at the quiz for the first two chapters in the 7th grade sequence. This is on adding, subtracting, multiplying, and dividing, positive and negative, integers, rationals, that sort of thing. So basically, your basic arithmetic with positive and negative numbers, along with decimals and fractions, mainly fractions and stuff. And then a little bit of absolute value thrown in there as well. So a lot of stuff goes by pretty quick. It's just a lot of rule memorization and a lot of the basics you need to tackle the higher stuff in math a little bit better, because if you know how to work with negatives on your own, it's a good base. Then when you get to the harder stuff, you don't have to think about it as much, and it's less stress on your brain. So we'll start with 9 minus 13. Well, if you have trouble doing this right off the top of your head, think about what's 13 minus 9. Think about 13 minus 9. Well, that's going to give you 4. Now, if it's 9 minus 13, that means I start with 9 and I take away 13, which means it's not going to be positive 4, but it's going to be a negative 4 because I'm starting with less than what I'm taking away. I'm only starting with 9, but I take away 13. That's more than what I have, so it's going to be a negative answer at the end. If you want to, you can also rewrite this problem as 9 plus negative 13. This, for some people, makes it a little bit easier because they can think about, okay, I have 13 negatives, I have 9 positives, cancel out the positive and negatives, and figure out how much is left. So they would draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 negatives and 9 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you're going to add these together, that means the positive and negative cancel out. So this cancels with that, this cancels with that, this cancels with that, this cancels with that, this cancels with that. Just go down the list here. This with that, this with that, this with that, and this with that. And make sure I bought this one out too. So in the end, I'm just left with 4 negatives that haven't been canceled, so my answer is negative 4. So if you want to make it into a plus negative problem, you can. You can always do that with any subtraction problem. Just change it to plus negative, and that way it's an addition problem now. What about this one? 16 divided by negative 4. Well, think about it as, what's 16 divided by 4? 16 divided by 4 is just 4. And the rule for division and multiplication is that if you have one negative, your answer is going to be negative. If you have 2 negatives, they cancel and make a positive, but we only have 1 negative in here, so the answer is just going to be negative 4. So think about what would it be normally, 16 divided by 4, and then worry about what sign you get at the end. What about number 3? Well, do the absolute values first. What's the absolute value of 5? Well, that's 5. Minus, what's the absolute value of negative 10? Well, that's 10. What's 5 minus 10? Well, 10 minus 5 is 5. But if I start with 5 and I take away 10, it's going to be a negative 5 because I'm taking away more than what I have. So negative 5 is my answer there. So do the absolute value numbers first, and then worry about whatever's outside the absolute value second. But this one, well, what's 4 times 3? 4 times 3 is 12. If you have 2 negatives, when you multiply, they cancel each other out and make one positive. So my answer is positive 12. Again, 2 negatives, when multiplied, make one positive. They cancel each other out. What about 5? Well, 5 is negative 10 minus negative 3. Now, if you hear yourself say minus negative, you're reading the problem out loud in your head, and you hear yourself say minus negative, that means that these two negatives, since they're side by side, with only a parentheses in between, they're going to make one big positive and make it into a plus 3. It's kind of like when you multiply 2 negatives, they cancel out. When you have 2 negatives side by side, they're also going to cancel each other out and make one big positive. Now, this only happens if they're side by side like they were on this problem. If there's something between them other than a parentheses, then you can't do this. If there was like a 5 or a 7 between these two minus signs, you couldn't do this trick. But this trick only works if the negatives are side by side or if there's just a parentheses between them. And so then we have negative 10 plus 3. Again, you can picture 10 negatives, 3 positives. Canceling them out, you get negative 7. What about number 6? Again, minus negative. 6 minus negative 4. Well, these are going to make one big positive. And so it's going to be 6 plus 4, which is just 10. Again, minus negative means turns it into one big positive. Now with fractions, the rules stay the same. It's just going to be applied to fractions as well. So if you have negative 27 eighths times negative 4 fifteenths, I'm going to think about first, how can I reduce them? Well, 8 and 4 can reduce, right? Divide both those by 4, so this becomes a 2. This becomes a 1. 27 and 15, those can both be divided by 3. Divide this by 3, you get 9. Divide this by 3, you get 5. And then I don't see anything else that's going to reduce, so I'm going to multiply them like I would a normal fraction. Whoops, didn't mean to draw that there. What's 9 times 1? 9. What's 2 times 5? 10. Now, is my answer going to be positive or negative? Well, I have a negative times a negative, so it's going to be a positive answer, so this is my answer, 9/10. Again, the rules don't change for fractions. They stay the same. It's just you also have the fraction rules to deal with as well. So two negatives, when multiplied, still make a positive, whether it's fraction, decimal, or whole number. For mixed numbers, again, you want to change them to fractions first. So if you don't remember, you take the bottom times the outside. That gives you 20. Don't worry about the sign. Just do 4 times 5. And then you add that to the top, which gives you 22 over 5, and then you keep the negative. So this is not negative 20 plus positive 2. It's just 5 times 4 plus 2, just as if the negative wasn't even there, and just keep the negative on the outside. Here, 10 times 5 is 50, plus 7 is negative 57/10. Now, before I add these, I need to get a common denominator, right? So between 5 and 10, the LCD would be 10. So I'm going to take this fraction and times it by 2 on top and bottom, because that will make it negative 44/10 plus negative 57/10. Makes it a little bit easier for me to add now because the denominators are the same. So if I add these two together, again, I'm going to add the top numbers because they're both negative. So if I have a negative plus another negative, I just add like normal and keep the negative. So negative 101 over 10. For me, this would be a perfectly fine answer. If you want to change it back to a mixed number, it'd be negative 10 and 1/10. Both these would work for me. But again, you do it like you would a normal mixed number problem. Change into fractions, add them following the rules. So since they're both negative, I add them together and make a bigger negative, so to speak. And then reduce your fraction at the end, if you want to. Or change the mixed number if you want to. Number 9 is the same way. Make this mixed number into a fraction. 3 times 2 is 6, plus 1 is 7. So 7/3 divided by negative 5/9. Now, some people say, what number does the negative apply to? And the answer is, it doesn't matter. The negative really is applying to the entire fraction. If you want to assign it to a number like just the 5 or just the 9, that's fine. But a negative fraction is a negative fraction. So it applies to the whole fraction itself. So how do I work this problem? Well, when I'm dividing fractions, remember, dividing fraction means the first one stays the same, and the second fraction flips. And then you times them together. So division changes to multiplication, 5/9 flips and becomes 9/5, and then now I'm back to multiplying. Now, before I multiply these, I'm going to cancel, because I can divide this by 3, and I can divide this by 3. Cancel them out. And then I multiply like normal. 7 times 3 is 21. 1 times negative 5, if you want, is negative 5. If you want to put the negative just with the 5, that's fine. But usually, again, if you have a negative number in the fraction, it applies to the whole fraction. So if I had two negative numbers in the fraction, they'd cancel out, make one positive, because they both apply to the same fraction, not individual numbers, essentially. So that's the front page. The back page is a short word problem. Whoops, too far. This is just kind of taking what we learned into a more formal format. So he's traveling at an elevation of negative 38.6 feet and then hikes up to an elevation of 56. What was the total change? Now, it helps to draw a picture here. So here's the path he's going. He starts down here. Let me try and draw the best I can here. So he starts down here at negative 38.6. And he's going to go, so this is below sea level. And he's going to go up and up and up and up and up until he ends right here. And this is now, he's at 56 feet. So I want to know, how far did he go from starting down here under the water all the way up to the top? How far did he travel? Well, he had to travel up 38.6 feet, right? He had to first go up that much, to get to 0. And then from 0, because right here, remember, water level is 0 elevation. Then to get to here on up, he has to go up another 56 feet to get to the actual 56 feet mark. So he has to go up 38.6 feet and then up 56 more feet. So in total, he's adding them together, right? He's going 38.6 feet plus another 56 feet. So he's doing them both. So it's an addition problem, not a subtraction problem, even though one of them is negative. So you have 38.6 plus 56, which would give you 94.6 foot or feet change in his elevation. He went up a total of 94.6 feet during his path there. Another way of thinking about it is that to get the total change, what you do to get the total change in anything, whether it be elevation, money, or anything else, is you take what you ended with, 56 feet, that's where it ended, minus what you started with, which is negative 38.6. That's how you find the change. You take what you end with minus what you start with. Just like a number line. Let's say if you have a number line here, and you start at 1, so here's you're starting at 1, and you jump to 5, 2, 3, 4, 5. So you jump to here, and I'm asking you, what's your total change? Well, you ended at 5, you start at 1, your total change is 4. You jump 4 spaces. Same thing here, just on a bigger scale. You end at 56, you start at negative 38.6, so how far did you go? Well, you went 94.6. Because remember, what happens with these two negatives? They make one big positive. Two negatives make one big positive, which leads you to the exact same answer that we got doing it the other way. But drawing a picture can help you avoid that entirely, because with the picture, it's easy to see that you have to climb 38.6 feet first, and then climb another 56 feet, so you're going to add them together to get your total climb, which is 94.6 feet. So that's the review for the first quiz over the operations with negatives and positive numbers. Hope you enjoyed the video. Have a good day.